Hello everyone, welcome back to my channel. So in this video, I'll walk you through how I built a fully cloud native resume website automated with Terraform, CI/CD and serverless architecture. So basically the Cloud Resume Challenge is a hands-on project that involves creating a resume website that is hosted in the cloud and secured with HTTPS, connected to a database, backed by serverless API and deployed automatically through a CI/CD pipeline. So most people attempt this challenge on AWS, but I wanted to push myself on GCP since I recently passed the A certification. So for me, it was the perfect way to take what I studied and apply it in a real world scenario. So if we go on GitHub, basically this is what you see. And in the README, you can read a basic summary of what the project is about. So basically, the static resume content is stored in a public bucket and served behind Cloudflare. And I use Cloudflare for DNS and CDN services because I didn't want to use the cloud load balancers because of the recurring costs. And then the page loads JavaScript that calls a Cloud Run hosted Flask API to increment and return a visitor count stored in the Firestore database. So all the infrastructure is managed using Terraform, and CI/CD is automated through GitHub Actions and CloudBuild. So to view this is an architecture. Okay, now let's trace the user interaction path in this architecture. The process begins when the user sends HTTPS requests to the address that's dimtayo.bata.online, and then the request first hits Cloudflare. Then Cloudflare acts as the DNS, CDN, or SSS layer, and it provides the global caching and HTTPS security, fetching the HTML page and CSS files from the bucket. Then once the page loads, the front end runs an AJAX call. This is the key piece. GET request is sent to the Cloud Run API to fetch the visitor count. Then the Flask visitor count API on Cloud Run instantly handles this request. It performs a read and increment operation on the backend Firestore database, updating the counter. Finally, Cloud Run returns the updated count as the JSON to the user's browser, completing the loop and then displaying the current visitor number on the resume that's at the bottom of the page. Now let's take a look at the automation that keeps this running. So basically, from my end, that's the developer. When I push the code changes either to the website or the API or to GitHub, the push automatically triggers a GitHub action. And then this GitHub action is a workflow, and then this action handles the continuous integration and continuous deployment process for the backend resources. So this is the core of this flow is Terraform, and Terraform manages all the necessary Google Cloud Platform resources, provisioning the Cloud Run service, setting up IAM permissions, enabling the Firestore database, and configuring the GCS bucket. This infrastructure as code pipeline ensures that the entire architecture is repeatable, it's version controlled, and consistently deployed with every code change. So let's start with the front end, hosting the resume itself. So I started with basic HTML and CSS, nothing fancy, just structured sections from my education, work experience, certifications, and projects. So the idea was to make it lightweight but professional. So let me walk you through the HTML structure of the cloud project. At the top of the file, I've included some standard metadata like the character set, viewport settings for mobile responsiveness, and a descriptive title for the page. I'm also linking an external style sheet so that the layout and styling are separated cleanly from the content. It's consistent. Right at the top, there is a button that lets visitors scroll directly to the counter section. Below that, I included my name, contact information, and quick links to my email, LinkedIn, and GitHub profile, making it easy for recruiters or hiring managers to connect with me. The resume itself is organized into different sections like profile, education, experience, certifications, skills, and projects. I also added a project section linked directly to my blog post about this challenge. The blog is the final part of the challenge and is mostly about documenting what I learned. So let's talk about how I hosted the main website. First of all, I started by purchasing my custom domain through GoDaddy. It's a domain registration website or portal. And then once the domain was registered, I didn't keep the default GoDaddy DNS. Instead, I switched to Cloudflare for better control and performance. So to do that, I updated the name server, the NS records inside my GoDaddy dashboard to point to Cloudflare's name servers. In my case, that's archer.ns.cloudflare.com and its pair. So from that point on, Cloudflare became the authoritative DNS provider for my domain. This setup lets me manage DNS records, caching, and TLS certificates directly through the Cloudflare, while still keeping the domain registered at GoDaddy. So once the custom domain was ready, I created a publicly accessible bucket and gave it the same name as the website. I then uploaded my resume files into the public GCS bucket because Google Cloud Storage can serve static websites directly. So to do this, it requires setting the right permissions so the bucket is publicly readable or accessible, and then enabling the website configuration to make index.html the default landing page. So on Cloudflare, here's where I made a key choice. Instead of using Google Cloud Load Balancers, I connected my GCS bucket directly to Cloudflare. So basically, Cloudflare is like a global cloud platform that provides services like DNS, CDN, that's content delivery network, and DDoS protection, SSL or TLS encryption, caching, and security for websites. So basically, I did this because of cost and simplicity. Google Cloud Load Balancers would have worked, but it adds a recurring cost. Cloudflare, on the other hand, gave me DNS, CDN caching, and SSL certificates for free. So here I am in the Cloudflare dashboard for my domain. You can see I've added 2 key DNS records. The first is a CNAME record that points my website to the domain to Google Storage APIs.com. That's the Google Cloud Storage endpoint that actually serves my static resume website. So with this setup, whenever someone visits the www version of my site, Cloudflare routes the request to my storage bucket. Next, I've added an A record for the root domain. And this points to Cloudflare's IP address instead of Google's because the cloud storage doesn't directly support naked domains. With Cloudflare, the root domain still works and is automatically proxied to the correct backend. So if you notice, both records have the orange cloud enabled. That means Cloudflare is not just resolving DNS, it's also acting as a proxy, giving me the benefits like caching, DDoS protection, and automatic HTTPS. So if you see under the SSL or TLS settings, I've selected the full strict mode. This ensures that the traffic between Cloudflare and my Google Cloud Storage bucket is fully encrypted with a valid certificate, not just traffic between visitors and Cloudflare. So what I mean is that the HTTPS is enforced from end to end. I've also enabled the option always use HTTPS so that any request over plain HTTP is automatically redirected to HTTPS. This guarantees that my resume website is always served securely. Finally, Cloudflare automatically provisions the free SSL certificates for my domain, so I don't have to worry about manually renewing or managing certificates. This simplifies everything and ensures that visitors always see the padlock symbol at the top when visiting my resume. So now when someone visits www.timtayaauthor.online, Cloudflare handles the DNS resolution, caches the content globally, and then provides HTTPS security while fetching the origin from my Google Storage bucket. So this setup lets me avoid paying for the load balancers, which are always on resources. Instead, you can use Cloudflare's free tier level, giving me the security and everything for free without extra bills. I think it's a neat hack to keep the architecture lightweight and cost efficient. At this point, my resume was live at the domain and globally distributed. The next step was to make it dynamic by adding a visitor counter, which means setting up a backend API and connecting it to Firestore. And I think that's enough for this video. I'm going to cover that much more detail in the next video. Thank you for watching.